Welcome back. Today we're going to be talking about the square root function. Okay, so this function is just, what it does is it takes the input x and it takes the square root of it. Okay, so it's sort of the opposite of squaring the function, right? Square rooting and squaring something are inverse operations, except that the square root function, as we're going to find out, has, you can't put negative numbers into the square root. Well, you can't put negative numbers into the square root and get back a real number. What you would get back is an imaginary number. So for, this is the first function that we really see that will have like a restricted domain here. Okay, so the first thing I want to do is start to think about values that might be good for me to put in for x. So let's say that we have a value 0, for instance. So the square root of 0 is 0. Or 1. The square root of 1 is 1. Now I'm going to skip to a value like 4 because I know the square root of 4 is 2. Okay, and let's say 16. The square root of 16 is 4. And let's see, 25. The square root of 25 is 5. And 36. The square root of 36 is 6. Now, I'm not really telling you the whole story here because actually when I take the square root of something like 16, what I actually get is two numbers. I would actually get plus or minus 4, for instance, or plus or minus 2, or plus or minus 1. Now, the problem with getting two output values for one input value is it no longer makes this thing a function. Right? So if I say, if I take f of 1 and I put it, so that would be the square root of 1, and I say, well, that's equal to both plus or minus 1, well, then there's a real problem because much like a computer program, you cannot tell a function to get two values because it just wouldn't know which one you wanted, essentially. So I always often think of functions like computer programs where you have to give them very clear directions. If you have this, then you have this other thing. So very clear rules. And remember, functions, relationships between two variables are only functions if there is exactly one output for each input. Or another way of saying that is, for each input, there's exactly one output. So if you try to graph these things all together, and you graph both the plus and minus branches, what you would end up getting is 0, 0, you'd get 1 and negative 1 here. You'd get, for 4, you'd get 2 and negative 2 right here. And so what would end up happening is you would have this, maybe do a little bit better here, you'd have this top branch like this, and then you'd also have this bottom branch that connected like this, if you tried to graph the plus or minus branch. Now, if you recall from our discussion about functions, one way to tell something's not a function is if you see the rule that if for one input you have two outputs, that means it's not a function. Or if you graph it and it doesn't pass the vertical line test. So here, I can just create a vertical line here and pass it over the function, and there are points at which the vertical line hits the function twice, or hits the relation twice, because it's not a function. So this makes it so it's not a function. So what we do instead is we restrict the domain. We say that we are only interested in the values of the square root function that are positive. So here we take away this idea of plus or minus, and we take away this bottom branch here. So we just sort of throw it out and say, you know what, in order for it to be a function, we are going to take away the consideration of the negative outputs here, okay? And that allows us to talk about the square root like it's a function. Or we're able to talk about a square root function. So here, we're going to restrict the domain. This is the first time we've really seen a restriction like this. So we're going to just talk about all real numbers greater than 0. Greater than or equal to 0, because we can include 0. Now, again, this is a restriction that we are choosing to include in order to make this relationship between the variables x and y also be a function. So we say we only want to input these values. Now, the range here is going to be all real numbers greater than or equal to 0. So the range is all these positive y values here, including 0, because of our restriction on the domain. Okay. Now, let's consider our end behavior. As x goes to negative infinity, what happens here? Well, x is not allowed to go to negative infinity, so this is not even a consideration. So y is undefined, essentially, meaning we're not defining values of y when x are negative. But as x goes to positive infinity, well, it looks a little strange because it does look like the function sort of approaches a horizontal line here. So what I want to do is just really quickly graph it on the graphing calculator and look at the table value so I can show you a concept here. So I go to y is equal to the square root of second x squared, because they're inverse operations, so they're related to each other. So we graph these values here. And so you see you have this right here. And if I took my window and I made it so that, I zoomed out, let's say, let's have a negative x so that it sort of frames it in the window so it's easier to see. Let's have this go up to 10,000. And then we don't need to include any y value, so I'm just going to put -1 so we can see the x and y axis here. And let's have the y values go to, I don't know, let's go to 800 here and see what we can see. Okay, so the function is growing, but it's not growing very fast, okay? So if I look at the comparison between, let me ask the calculator, calculate the value of, I don't know, x is 3,600, for instance, okay? When x is 3,600, y is 60. So when x gets large, y also gets large, but it doesn't grow as much as the functions we've been seeing. So if I just look at the tables here, second table, if I want to change, like, if you press the plus key and say that you want the table to increase by, I don't know, let's say 100 each time. You know what, let's go crazy, let's say 1,000. So it's going to go 0, 1,000, 2,000, and so on. So even at large values of 15,000, it's only 126, right? About. So we can get the x gets larger and larger at a faster rate, and the y also gets larger. So the end behavior is still going to be, as x goes to infinity, y goes to infinity, because it does get larger. There isn't a value of y that it stops at, but it does increase at a very slow rate. Okay, because you're taking the square root. So imagine you're taking all, let's look at this table again. All these values, like, 26,000, what you're doing is you're taking the square root of those values. So it really reduces, the input gets really reduced in order to get the output. Okay, so it's increasing, just not very fast. Okay, and we're now, again, this is the same pattern that you're going to see in Algebra 2. We talk about a parent function, and then we're going to talk about the transformations of the function. So there's a few characteristics I think we should have noted here. First of all, this is the point 0, 0, right? That's it's not called a vertex, but that's like the starting point of the function. So with every transformation, basically we're going to take this function and sort of move it around. So we have 0, 0, and then unless it's been vertically stretched or compressed, the next point is going to be up 1, right 1. And then the next point is going to be up 1, 2, 3, or right 3 and up 1. Okay, so this is 1, 1, and then 3, 1, and so on, unless you have a compression or a stretch. So here we had the parent function, and we're adding 1 to the input. Okay, so basically this is like saying g of x plus 1, right? I'm adding 1 to the input. That's another way of writing it. So you're adding 1 to the input, and then you're adding 4 on the outside. So remember, this right here represents a horizontal change, okay? And this represents a vertical change. So this is like your hk. So your starting point is going to be, in this case, -1 and 4. Whoops. Oh yeah, that's right. -1, so it's 1 to the left and 4 up. So let's plot that point right here. Now essentially, what used to be at your origin, like this, 4 was 2, so it used to be like this. Now you're starting here. But the next one, since there's no number on the outside here, there's no value here, there's not going to be any vertical compression or stretching. So essentially, you're going to follow that pattern of right 1, up 1, right 1, 2, 3, up 1, okay? And that would be your original 0, 0, and then 1, 1, and then 4, 2. Now gets you, so here if I plug 0 in, right here, I'd have 0 plus 1, which is 1. Square root of 1 is 1, plus 4 is 5 here, okay? So essentially this is your graph right here. And remember, it just literally stops here. Right? It's not going to be a double pointed arrow. It's just going to be a curve with a single arrowhead on it. All right, now if you are having trouble with that, if you can't remember how to do that on the regions, all you do is just go to your graphing calculator. Let's clear out this function here, and let's just put the entire function in. So we have x plus 4, plus 1, and then arrow to the right. So right now you're still underneath the square root bracket or the radical sign. So arrow to the right, it closes that bracket off, and then do plus 4 right here, and then graph it. Now we had some pretty crazy values in the table, so let's just go back, second table, right here, and what you do is go down to essentially like 1,000, or you know what, actually, it's easier to go down to 0 and then press the plus key and say that you want the increments to go up by 1s, okay? And then we'll go back to the ones that you've seen before. So what you're gonna notice is that you have -1, 4, and anything below that, it's gonna say error, right? Because it's not defined for values that make the expression underneath the square root. So now the expression is being added by 1. Let me get rid of that right there. The expression x is being added by 1 is being added to x before it's put into the square root. So the function will take in, you can put in -1 because it doesn't make the expression negative, but you can't, you just can't put in anything that's less than -1. So you saw that on the graphing calculator here because it's going to make it negative under the square root. So basically what you're going to see on the regions is it's going to ask you to graph it in a certain range. So that's what this means. It says choose x values between -1 and 10. Okay, well just go use your graphing calculator, hit graph, always hit graph first because it's not going to create the table unless you hit graph. And then pick up some values. So you have -1, 4. Pick up some integer values for both. Pick up values for which both the coordinates are integers. -1, 4, 0, 5, 3, 6. So make a little table here. -1, 4, x, y. Let's say 0, 5. What were some other values here? Let's see. 3, 6, and anything else here before 10? 3, 6, and 8, 7. And at 10, it's about 7.3. Oops. Okay, and so we had 8, 7, and then we had 10, and it was about, let's see, 7.3. Okay, so what you do on the regions if you're asked to graph this, pick some values. So go ahead and graph on your graphing calculator and then pick some values within this range that you can get integer values for. Then choose your endpoints and sort of estimate your endpoints. So let me go back and just try this again. So you'd have -1, 4, like this, then 0, 5, and then 8, 7. So you have 8, 7 here, and then you have 10, and it's about 7.3. So make a little table like I did on the right there and just try to draw it as smoothly as possible. Okay. Our domain here, all the numbers we're allowed to put in is all real numbers greater than or equal to -1. Remember that. That was the number for which you had 0 under there. Anything less than that's going to make it negative. And then our range are all real numbers greater than or equal to. And so we're starting here at like 4 begins. We get all real numbers up from 4, greater than or equal to 4. Okay, and so the end behavior is going to still be the same. As x gets really negative, y is undefined, and as x gets really large, positive in a positive direction, y also goes to infinity. Okay, so one more transformation here. So you'll notice there's actually 3 transformations here. We will see the reflection here. We see the horizontal shift left, and we see a vertical shift down like this. Okay, so you are going to graph it for the domain that it's defined by. So remember, our first step is go ahead and so just to visualize it, it's been shifted left, then up, and then it's actually it's been shifted left. So the first thing we encounter is the green. So it's shifted left, and then that's been reflected, and then the whole thing's been shifted down by 4. Okay, so I'll show you it. Let's graph it. Okay, so we have negative square root of x plus 2, and then outside the parentheses or outside the square root radical, we have -4. Okay, Let's go ahead and graph it. Okay, and we don't see it because our window. So let's just go back to zoom 6 and that we'll get it back. There we go. So originally it was like this. It was shifted left, then reflected down, and then shifted down like that. So it's the order of operations was left, reflection, and then down. Let's go ahead and look at the table here. So we're going between, let's see, -2 and 10. So some values that we might want to check out here are, let's go to -2. So here, -2 gets -6. Oh, that's just 2 rather. -2 gets -4, and that's where it begins, okay? Everything less than -2 is an error. -2 gets -4, and then -1 gets -5. So just go ahead and translate those. Okay, so I just wrote down some values pretty quickly here. And let me go ahead and plot them. Remember, I picked the endpoints that they gave me right here. And then I just picked other values that were integer values that were easy to plot so that I can make kind of a smooth line here. So -1, -5, 2, -6, 7, -7 here, and then at 10 it's about -7.5 right here. So here's my square root function, and I didn't really draw it smoothly enough here. So let me try this one more time. Okay, so it actually should just go through the points right there. Okay, so there's my square root function. It's not very nice and neat. Hopefully yours is a little bit better. But the point is, or the thing to take away here is that you might not necessarily know what this looks like, but you are given access to a graphing calculator. So go ahead and graph it. The idea of transformations should give you some idea of what it should look like. Use the values that they told you to graph it on to create endpoints, and then find integer values in between so that you can create hopefully a smoother looking curve than I've created. The domain here, so this is a little weird because it's been reflected. So the domain here is going to be anything that makes this greater than 0. So what you could actually do is you could take the expression in here and set up an inequality and solve the inequality here. So you could go, well, what is x plus 3? What's going to make that greater than or equal to 0? Well, if I subtract it, 2, remember how you can just solve these equations really quickly. So you are allowed to put in all real numbers greater than or equal to -2. You could have also seen that if you had gone to the calculator and you saw error messages after -2, so that can help you figure that out too. All right. Now my range is a little strange because my range is actually, because it's been reflected, it's getting my negative y values, not positive y values. So my range is, so imagine I drew like a vertical, a dashed line here. My range is any value of y below -4. So my range is all real numbers less than or equal to -4, okay? And my end behavior is also, actually, it's as x goes to infinity, right, y goes to actually -infinity because it gets smaller and smaller because of the reflection that's going on outside here. And again, as x goes to -infinity, y is undefined. So that remains the same. Okay, so hopefully that's given you some idea of how to graph square root functions and some transformations on square root functions. To get an idea of what it looks like, always just grab your graphing calculator, put it in, make sure to put it in correctly, use your table to get values, and use that to plot a graph on your paper. And that's the end of the lesson for today.